Hello my dear students. So here welcome to this next video. Here we are doing a problem which was asked in 2024 as question 12, right? So here we have a question from complex analysis. So I have also added the topic in the title of the video so that if you are preparing for one particular topic you can just do those problems first. So here you see they gave you an ellipse, right? And then it is traversed in counterclockwise direction. You have to find out the value of this contour integral. So basically you can see that when you are given an ellipse, you should understand that what they are talking about. When the equation of the ellipse is given in this form, it means that this 2 and minus 2, they are the focus, they are the foci point, right? Because what you are saying that the for any point on the ellipse, the sum of the distance from the two foci is a constant, right? So that is the property of the ellipse, right? That is how we make an ellipse, right? So you can see that this is there. So you have this z minus 2 mod plus z plus 2 mod is equal to 8. Okay, fine. So now the ellipse is traverse in the counterclockwise direction. So you have to find out this. So can you tell me what theorem comes to your mind, right, when you see this? So this is equal to 2 pi I iota times sum of residues, right? What is this? This is called Cauchy residue theorem, right? Cauchy residue theorem. So what you have to do here, you have to find out your residues. So what are residues? First of all, we have to see, is there any singularity of this function? If is there any singularity of this function inside the ellipse, right? So for singular points of the function, your f of z is z square upon z square minus 2z plus 2. So for singular points, you put it equal to 0 and you solve it. So you'll get z is equal to 2 plus minus b square minus 4ac upon 2a. So that is 2 plus minus square root of minus 4 upon 2, that is 2 plus minus 2 iota upon 2. So this is 1 plus minus iota. So you have to see whether it is within the ellipse or outside the ellipse. So what do you think? So this is your 0, right? So this is the point 1 comma 1, right? So 1 is 1 comma 1, 1 is 1 comma minus 1. 1 comma 1 will be somewhere here and 1 comma minus 1 will be somewhere here. So both the points are inside the ellipse. So you can, if you are not good at visualization, you can just put it here and check, right? So both these points are inside the ellipse, right? How do I check? For example, if I do this thing for this point, say 1 plus iota. So this is minus 1 plus iota mod plus this is 3 plus iota mod. So this is 1 plus 1, this is 9 plus 1. So this will be square root of 2 plus square root of 10. So this will be 1 point something. This will be 3 point something. So you'll get 4 point something, which is less than 8. So you are inside ellipse because equation of the ellipse is equal to 8, right? Similarly for the other point. So both the points are in the ellipse. So therefore our answer would be integral of this z square upon z square minus 2z plus 2 dz would be 2 pi iota into residue of f of z at the point z is equal to 1 plus iota plus residue of f of z at the point z is equal to 1 minus iota, right? Now, how do you calculate residues, right? What is residue? Residue is actually, if you look at the definition, so residue is the coefficient of 1 by z term in the Laurent series expansion of the function around the singular point, right? So what is residue? So that you know that residue is basically coefficient of 1 upon z in the Laurent series expansion. So if you have to do that complex analysis course, expansion of f of z around the point of singularity. Okay, and if it actually tells you that what is the strength of the singularity at that point, right? it tells you what is the strength of the singularity at that point. Okay. Now, if you have an isolated singularity, for example, these two are isolated singularities, right? You can find a domain around these points where there is no other singularities. For isolated singularities, right? So, for isolated singularities, especially for poles, simple poles means you have only poles of order 1, right? Poles of order 1. So the formula for residue is limit z going to a, residue at the point a is limit z going to a f of z into z minus a, if you have a pole of order 1, right? So here we have 1 plus iota as a pole of order 1 and 1 minus iota as a pole of order 1. So residue at 1 plus iota would be z minus 1 plus iota into my f of z, which is z square, and in the denominator I'll make the factors so that the things will cancel, because I already know the factors, right? Limit z going to that point 1 plus iota. So this cancels. So you get this is equal to 1 plus iota square upon 1 plus iota minus 1 plus iota, right? So this is 1 plus iota square upon 2 iota. You can just calculate it. So this will be 1 minus 1 plus 2 iota upon 2 iota. So answer is 1. Similarly, for the other pole, so that will be limit z going to 1, that is the 1 minus iota. 1 minus iota z minus 1 minus iota into z square upon z minus 1 plus iota z minus 1 minus iota. So this and this cancels. Now you put 1 minus iota, 1 minus iota square, and here you have 1 minus iota minus 1 minus iota minus 1 minus iota. So that will give you how much? That will give you 1 minus 1 minus 2 iota upon minus 2 iota. So that is 1 again. So your answer will be 2 pi iota into sum of the residues. So answer would be 4 pi iota. Okay. So you can go to your options. So this C is your answer. Okay. So I hope that is clear. If you have any doubt, please write in the comment box. Thank you for watching this video. Please share this video and subscribe to this channel. Happy learning.